So to start off with atoms, we all know that atoms make up matter, but we can define an atom as the smallest particle of an element that still retains the properties of that element. Okay. So think of like a piece of copper, right? We can split it down and split it until we finally get to the atom of copper. That atom of copper still has the same properties as like a large chunk of copper. Okay, so that's how we define what an atom is. Could we split an atom further? Yeah, we could split it up into like protons, neutrons, and electrons. However, protons, neutrons, and electrons no longer would have the same properties of copper. So like that's where we draw the line of like what is an atom. Okay, so smallest particle of an element that still retains the properties of that element. To give you an idea of the size of an atom, I have a little comparison down here. When I switch to my recording software, it doesn't like scientific notation. Okay. How many people are on planet Earth? Roughly. It's like, I think we're close.
Like 7, I think you just go to 8 billion.
Almost 8 billion. I did 7.9. I think like we're really close to 8 billion. Okay. So all the people on the planet, I have 7.9 billion, so that's times 10 to the 9th. Okay, so like we're getting close to 8 billion. Is that so many people? Can we even like picture that in our head? Probably not, right? Like 8 billion is a really large number, okay? But this is what it would look like in scientific notation, okay? Now in just one little penny, there's 2.4 times 10 to the 22nd atoms of copper in just one little penny. So what does that tell you about the size of atoms?
Tiny.
Okay, small. Does small even like do atoms justice? No, okay, like really, 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 really tiny. Okay, if you can fit that many atoms in a penny, that means that they must be really, 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 really tiny. What are the 3 big parts of an atom? Someone tell me one. Protons. What else? Neutrons. Electrons. Okay. So today we're just going to refresh. We call those subatomic particles. Okay. I'm going to change the slide. These are on the next slide as well. Okay. So when we talk subatomic particles, you need to know that our subatomic particles are protons, neutrons, and electrons. And then you also need to know the charge, the location, and the mass. Okay, so we'll go through them. So essentially, you need to know this table. Hopefully, it's a review. If it's not, should you be writing it down? Yes. Okay, so protons have a positive charge. So we write it as +1. Think P for proton, P for positive. Okay. Protons are located in the nucleus. And they have a mass, we say 1 AMU. After we go through the chart, I'm going to circle back to what AMUs are. Okay. Neutrons have no charge, or they're neutral. Okay. They're also found in the nucleus. So think like N for neutron, N for neutral or no charge, N for nucleus. Okay. They have a mass of 1 AMU. And then finally, electrons have that -1 charge or a minus charge. These ones are outside the nucleus, and they have a mass of 0 AMU. Keep it. It's for you. Okay, so let's talk AMUs. Have you ever seen AMU before? Okay, AMU stands for atomic mass unit. Ooh, that's a T, unit. Think of this as like a man-made scale to make the masses of the subatomic particles easy to work with. Okay. Earlier we watched the video of the mass of like an electron. If we were to be able to capture an electron and calculate the mass, would it have an actual mass? It does. We measured in grams, and I don't remember the first number, but it was something times 10 to the -28th. So what does that tell you about the mass of an electron? Really, 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 really small. Okay. Protons and neutrons also have a mass. If we could measure the mass of a proton and neutron, they too would have a really small number. Theirs are like, I think something times 10 to like the -22nd or -26th power. Okay. Again, really, really small numbers. Is it easy to work with really small numbers? No. Okay. So chemists came up with atomic mass units to make it really easy. So they set the mass of protons and neutrons equal to 1, and then the mass of an electron equal to 0. Okay. Do electrons really have a mass, though? Yes. Okay, it's just tiny. And we set it to 0 because the mass of an electron is so small, we would say it's negligible. What does negligible mean? Unimportant, right? Like the mass of an electron is so small compared to a proton and a neutron, it's unimportant. Okay, so we use simple numbers, ones and zeros. However, do electrons actually have mass? Okay, they do. It's just really tiny. Usually someone gets tripped up on this every year because our electrons still matter. Okay, matter has to have mass. All right, so today we're just going to either learn or refresh how to count the number of protons, neutrons, or electrons in an element. So you all have a periodic table. Look at your periodic table in front of you so you can start getting familiar with it. Most periodic tables will come with a key. Okay, yours is at the bottom left. And that key, it just tells you where certain things are listed on the periodic table. So like where's the name, where's the atomic number, where's the symbol, and where's the mass. Okay. So take a look at your key on the bottom left. Where do you find the atomic number on your periodic table? Okay, on yours it's going to be top left. Okay, so the atomic number is going to tell you the number of protons. So everyone find magnesium. Its symbol is Mg. It's on like the top left of the periodic table. What's the magnesium? Mg, top left. What's the atomic number of magnesium? 12. So how many protons does magnesium have? 12. 12. Atomic number equals protons. Okay. Protons also IDs the element. Okay. If any atom has 12 protons out there, it will always, always, always be a magnesium. Okay. If you change the number of protons, you change the whole element. So find 13 on the periodic table. What element is 13? Aluminum. Okay, so protons always identifies the element. For today, the number of electrons are going to equal the number of protons. The key is for a neutral atom. Okay, so today we're only going to talk neutral atoms. What does neutral mean? They're just there. Neutral means that there's no charge. Okay, so atoms that don't have an electric charge, we call them neutral. So that means number of electrons equal number of protons. And that should make sense because what's the charge of a proton? What kind of charge does a proton have? Positive. And what's the charge of an electron? Negative. Does one positive cancel out one negative? Yes. So they're going to be neutral. Okay. This is for today only. Friday, we're going to start learning about ions, which are charged atoms. This rule is not going to apply on Friday. Okay. You with me there? So this rule is good for today. When we talk electrons, there are some very important electrons called valence electrons. Did you learn about valence electrons in your physical and earth science class? Give me a nod, yes or no. Okay. It sounds like some of you did, maybe some of you don't remember. Valence electrons are super important. Where do you find valence electrons? Okay, they're the outside shell, your very outermost electrons. And the reason why they're important is if you think about an atom bonding, are the inner electrons going to bond or the outer electrons? Outer, okay? So the reason why we care about valence electrons, it's going to tell us which atoms are going to want to bond to what other atom, okay? So the rule of thumb, most atoms want 8. Okay, so make sure you write this down. Most want 8. H and He want 2. What is H and what's He? Okay, so hydrogen and helium, they're exceptions. They only want 2 electrons. But then for the most part, all the other atoms want 8. And then finally, we're going to learn how to figure out neutrons. Neutrons are just a little tricky because it's just not straightforward on the periodic table. So to find neutrons, we have to find the mass number. Okay. And if you look at that chart we just copied down, what 2 subatomic particles have a mass of 1 AMU? Someone say that louder. Thank you. Protons and neutrons, okay? So when we care about mass, we're only interested in protons and neutrons, okay? So our mass number is protons plus neutrons. I'm just going to rearrange that to solve for neutrons. Okay, so neutrons is your mass number minus your number of protons. Okay. Here's the issue, though. If you look at the key on your periodic table, do you have something that says mass number? Okay. On that key, do you see anything that says mass number? Okay, so that's the issue. The mass number just isn't on the periodic table. What do you see that looks similar to mass? Okay, your periodic table says atomic weight. Some other periodic tables might say atomic mass. Okay, so you get the atomic weight on your periodic table. If we're looking at carbon, can you have 0.01 neutrons? Okay, so all you do is you take the atomic mass or the atomic weight and you round it to the nearest whole number. So what would you round 12 to? Or 12.01 to?
12.
Okay, so you're just going to round it to a whole number. So you're going to round it to 12. Okay. So that plugs in for your mass number. And then how many protons are in carbon?
What did you say?
How many protons does carbon have? 6. So what's 12 minus 6? Okay. I'm just going to say N for neutrons. Okay, so neutrons, they're just a little bit tricky because you have to do subtraction. Okay, you got to round and then subtract. Let's do like another practice problem just to practice neutrons. I'm going to write it over here. Let's find fluorine on the periodic table. Fluorine symbol is F, and it's like in the top right. Okay. What's the atomic weight of fluorine? 99. Okay, so what would you round 18.99 to? Okay, and then what are you going to subtract? 9, which is the atomic number, so it's 19 minus 9. Okay, so then fluorine would have 10 neutrons. You with me? Okay. So now we're going to put it all together. We're just going to count protons, neutrons, electrons, and then we'll just draw some atoms. So we're going to start with helium. Before you can draw an atom, we just have to know how many protons, neutrons, and electrons are in the atom. How many protons are in helium? Okay. How many electrons? I'm going to skip down to electrons. How many electrons? 2. Okay, then how many neutrons? 2. Okay, let's look at how we found 2. What's the mass of helium? Is it 4.01? 00. Oops, hold on. Okay, so if you look at your periodic, your table, yours says 4.0026. Do you agree?
Yeah.
Okay, what are you rounding that to?
4.
Okay, you round it to 4. And then you're taking 4 minus your number of protons, which equals 2. Okay, if you weren't sure where this came from, write this out so you have an example of how we got to 2.
Is protons the atomic number?
Yes,
Okay.
always. Okay, then we're going to draw the atom. The way we draw atoms, we're going to follow the Bohr model because the Bohr model is like the easiest one to diagram on paper. Okay, so what goes in the nucleus? What 2 subatomic particles go in the nucleus? Okay, protons and neutrons. You don't have to get like creative and draw 2 individual protons or 2 individual neutrons. Okay, 2p for protons and 2n for neutrons is all you need. And then where are electrons found? Okay, they're moving around the nucleus. What's nice about the Bohr model is Bohr draws these rings. Okay, and it makes it easy to diagram. Do electrons actually move around the nucleus in like a fixed path? Okay, that's no longer accurate, but they do fall into like shells, and it's a good way to diagram. Okay, this first ring, write yourself a note, it can only hold up to 2 electrons, and we abbreviate electron, which is an E and a negative charge. Okay, so that first ring holds 2, and how many electrons are in helium? 2. Okay, what kind of charge do electrons have? Negative. They're both negative. What do like charges do? Do they want to be near each other or far away? Far away. So when we draw our 2 electrons, you're going to put them on opposite ends of the atom. because like charges repel, okay? Those two electrons, do they want to be near each other? No, they want to be as far apart as possible. Okay, are you okay if I move forward? Oh, okay, we're going to do the same thing for carbon. So I want you to count your protons, neutrons, and electrons for carbon on your own. How many protons in carbon?
6.
Okay, I'm jumping down to electrons. How many electrons? Okay, also 6. How many neutrons? Okay, also 6.
How do we know how much electrons are?
For today only, protons and electrons are going to be equal. Okay, we're going to start looking at charged atoms Friday, so that's not always going to be true. But for today, protons are going to equal electrons. All right, then we're going to draw our atom. What goes on the inside of the atom?
P and N.
P and N. So we have 6 protons, 6 neutrons. Where do we put the electrons? Okay, outside. We draw them on rings. How many electrons can go on the first ring?
2.
Okay, 2. Do they want to be close or far apart?
R.
Okay, so I'm going to draw them far apart. Okay, how many more electrons do we have to draw?
4.
Okay, we need 4 more, so you're going to draw a second ring.
Can this one only hold 2?
Nope. This ring and every other ring can hold 8. Okay, so if you want, draw yourself a little note. All the other rings can hold up to 8. How many are we putting on there, though?
4.
4. Do those electrons want to be near each other or far apart? Okay, so I'm going to place it if I'm like referencing the clock. Okay, one's going to go at 12 o'clock, 3 o'clock, 6 o'clock, and 9 o'clock. Okay, they want to be spread out as far apart as possible. Okay, our last one is aluminum. So go ahead and count protons, neutrons, and electrons for aluminum. How many protons?
13.
Okay. How many electrons?
13.
13. And then how many neutrons? 14. Okay. What goes on in the nucleus?
P and N.
Okay. So we have 13 protons, 14 neutrons. Please don't try to draw like little circles for protons and neutrons. Okay, that's going to take you forever. So you can just write 13 protons, 13 neutrons. How many electrons do you have to place? Okay, how many are going on that first ring? 2. Okay, and we're going to spread them apart. How many can go on the second ring? Okay, 8. Let me show you how we place the electrons. So those first 4 are going to go at like 12, 3, 6, and 9 o'clock. Okay. How many more electrons can this ring hold? 4 more. Once all 4 of those places are filled, we're going to go back and they're going to buddy up. Okay. In 2 more chapters, we have a whole chapter on electrons. And this whole like buddying up thing, this is part of the quantum mechanical model. Okay, so like if we get used to pairing them up right now, when we get to quantum mechanical model and how electrons actually fit into shells, this is going to be really familiar to us. Okay, so for today when we're drawing them on paper, they spread out if they can, but if they can't, then they pair up. Okay, you with me there?
Yeah.
Okay, how many more electrons do we still have to draw?
3.
Okay, so you have to draw another ring. How many electrons could this ring hold? 8, but we're only going to draw 3, and we're just going to stick to that 12 o'clock, 3 o'clock, 6 o'clock pattern.